Okay, pre-calc, this is your last lesson in trig. This is the grand finale here. A little sad, I'm a little sentimental about it. I don't know. I love trig. I don't know about you guys. There might be some mixed emotions and feelings about trig out there, but this is pretty much it. Bearings are a very specific application of some real life examples using trigonometry. So I'm going to just show you how bearings are sketched, and then we'll see some real life problems about where some information about bearings might be given. And what it's really going to boil down to is most likely the use of law of sines and law of cosines to find what we're looking for. And there are two types of ways that bearings will be provided to us in problems. Type 1 is if you're given two directions. So for example, if you're north 42 degrees east, the way you would sketch something like that is you would first maybe draw a line due north. Okay, so on the page that might look something like this, straight up. And then east to me would be going to the right. I hope that would be the same for you. You know what? We should probably, just to really make sure, draw this up here that we got north and south, and we've got east and west. Okay, just to make sure we're good with all those directions. But if I said north 90 degrees east, it would actually be directly to the east then at that point. So you'll see that this will always be an acute angle in here. And north 42 degrees east, well, halfway to due east would be 45 degrees, right? So it might look something like this. Okay, an angle of north 42 degrees east might look something like that. All right, so that's how I'd sketch that first bearing. Similarly, if I had south 79 degrees west, we would want to draw a line due south first. So there we are. 79 degrees to the west of that. Well, west up here is headed to the left then on the page. So remember, directly west would be this way. So 79 degrees is pretty close to that. So if we're trying to be accurate about our sketch, that the bearing would be something like this. And, maybe it's a boat or something traveling in this direction. Add that bearing south 79 degrees west. Okay. Beyond that, you'll also see bearings given in the second type, which is just one solid angle. And you'll see 123 degrees, 304 degrees. What you're going to do is you're going to sketch these in a clockwise direction from the due north position. Okay, so a little bit different than how we traditionally sketch angles in trigonometry, which is usually from the right side of the x-axis. We're actually going to start on what would look like, I guess, the y-axis to us, the line that's going due north. We're going to sketch clockwise from there. So kind of like think about starting at 12 o'clock and rotating this number of degrees. So for example, 123 degrees, what that might look like is if I do this, here's kind of where like a bearing of 0 is up here. So here's 90. This would now be 180. So a bearing of 123 degrees might look something like this. Okay, so we're traveling in this direction, which would be, if I went back to the way bearings are listed up top, this is like a southeasternly direction, right? We could probably even write it in that format that we have up above, that it would be south. And then I guess the east direction would be what's kind of left on this side, right? So if it's south, if this is 123, add another, I think 57 sounds right to me. This would be the same bearing as south 57 degrees east. You won't have to transfer bearings like I just wrote down right here, but just to kind of play off of what we were doing up here, those would be going in the same exact direction. 123 degrees south, 57 east is the same. And finally, 304, if we think about what that might look like. 304, if I start, with this due north line, this would be 90 going directly east, 180 is south, 270 is directly to the west. So 304 is actually going to rotate all the way around this way and be headed in a northwesternly direction. Okay, so that's what that bearing would look like. And most likely what we're going to need to do is we're going to need to, in our examples, probably identify what this angle is right here, formed with this horizontal due west, and also the direction that the bearing is going in. So just as a quick aside, how would I find where that question mark is? Well, I would take 304 and subtract, well, if I've gone 3/4 of a circle up until this point, you would actually subtract out 270 to get that this part is 34 degrees. We don't always have to do something like that, but just as a quick, hey, this is kind of interesting in our context of what we would be doing in questions. And if you open the compass on your phone, guys, I thought it's pretty interesting. Actually, when I opened it, I don't know why it freaked me out a little bit, but I opened my phone and it said I was directly sitting at 0 degrees north. I was like, wow, I am headed, and based on where I just sat down at my table here, I was at 0 degrees north. But as I turn my phone, you can kind of see how this angle changes, right? So this would be a bearing of 41 degrees, headed that way. It tells me the direction's northeast. But if I keep spinning this around, look how eventually I get to a place where the bearing is now 232 degrees, and that's a southwesterly direction. So again, this is the compass app on your phone, just kind of a quick connection there. And it even tells you the location of Fairport, New York in degrees, minutes, and seconds. How awesome is that? So, we talked about degrees, minutes, and seconds. All that's there for us. We're apparently at a 430-foot elevation. Cool stuff going on in this compass app. So check that out on your phone. See what, based on where you're sitting in your house or what direction your house faces, maybe what bearing your house is at. So, all right, let's actually get into some questions, and you can see where bearings will be given to us in the question and how that might apply towards setting up some fixtures. Okay. So number 1 says, radio direction finders are placed at points A and B, which are 4.72 miles apart on an east-west line, with A west of B. Okay, so that will be important information for our diagram later on. From A, the bearing of a certain radio transmitter is 39.8 degrees. From B, the bearing is 307.2 degrees. Find the distance of the transmitter from A. Okay, so if I go back to the beginning, these radio direction finders A and B, if you kind of go a little bit further into the question, it says they're on an east-west line. So east-west line on your page should be going left and right. And it does say that A is west of B. So you should put A on the left endpoint and B on the right endpoint. And what do we know? We know that the bearings to a certain transmitter from A is 39.8 degrees. So since there's no 2 directions given there, you're going to have to start with the line due north, right? Start at kind of like 12 o'clock and sketch an angle of 39.8 degrees, which is not quite halfway to this line, right? So if we're trying to be a little bit accurate about the sketch here, that would be 39.8. Okay, and then if I go over to point B, it says that the bearing from point B is 307.2 degrees. Okay, so again, start due north from point B. And if I go 307.2, we'll remember that directly to the right would be 90, down would be 180, left would be 270. So 307.2 might look something like this. Definitely stop short of going a full 360. And you can see that if I connect that, that bearing, that eventually these two will meet up. And that's where that radio transmitter is located. Okay. So again, that total angle is 307.2. And what else do we know? Oh, wait, the radio direction finders are 4.72 miles apart. So I forgot to label this, that this distance is 4.72 miles. And then finally, the question's asking, find the distance from the transmitter. So the transmitter is somewhere at that location, right? To from A. So I want to find this distance right here. Okay, so it's a little bit to set up the diagram. I hope that these two bearings, as we sketch them, made sense in terms of we're sketching from due north and then rotating the number of degrees that we're given. But notice how neither of those bearings are actual angles inside this triangle. So that will be pretty much the goal, is to use that information to then find some angles on the interior, because we need to know some angles on the inside if we're going to find this side labeled as X. So quickly on the left where point A is, at point A, there's definitely going to be a right angle formed with the north and the east-west line, right? So if you do 90 minus the 39.8, you'll find pretty quickly here that the other angle is 50.2, the complement here. So there's an angle right away. Okay. Now, if you remember what I showed you on the last page, notice how this is that same situation that, up until this point, I've gone 270, right? If I do 3/4 of a circle, so I can figure out how much do I have left to get to 307.2, or I can take that 307.2, subtract out 270, and that should be a 37.2 degree angle. And if I know two angles in the triangle, well, I could definitely find angle T by doing 180 minus 50.2 and minus 37.2 to get 92.6 is what's left up here. And I really did need that angle because it's across from this side right here. So when you have as many angles as we have, typically it's going to be a law of sines case, and we should have enough info. Now, we haven't probably touched law of sines in a little while, maybe since I guess that ambiguous case lesson wasn't too long ago. But in this application here, you're going to pair up 4.72 over sine of 92.6, right? That would equal the ratio of x over sine of 37.2. So go ahead and set up your law of sines then. 4.72 over sine of 92.6 is equal to x over sine of 37.2. The hardest part about bearings, to be honest, is the diagram. So if you guys can get to a good place where you do enough practice and you understand how to set up the picture, typically the law of sines or cosine step is going to be pretty easy. All right, go ahead and cross multiply. X sine 92.6 equals 4.72 sine of 37.2. So if you divide both sides by sine of 92.6, you'll get that the distance from the transmitter, or from A to that transmitter there, is, let's check it out, 4.72 sine 37.2 divided by sine of 92.6 is, did I type that all in right? 2.86. We'll go to the hundredths place here. So 2.86 miles is that distance. Better check with the filled in notes, make sure that these answers are correct. That looks right to me, but yeah, that's what I got too, 2.86. Okay, perfect. So there's our first example, sketching some bearings. Again, these were two bearings that were given just in terms of their number of degrees. So you start due north, sketch them clockwise. On the next page, we have two examples. I'm pretty sure every other example today has something to do with sailing a ship. And I tried to find a good model of this for you. The best I can come up with is I have Mickey on this little boat here that, so hey, Mickey. I thought I had a smaller version of that, but apparently not. It's all right. Mickey made a guest appearance. We're going to do a lot of sailing here, people. So get your sailor hats on and get ready. Okay, a lighthouse A is 15 miles from ship B and 31 miles from ship C. Okay, so that's good info, but I'm going to hang on that for a second until I know the bearings that are given. The bearing of B from A is this right here. So we get that northeast bearing. We've also got some degrees and minutes to work with. Don't be afraid of those. And the bearing of C from A is north 76 degrees, 40 minutes east. Find the distance from B to C. Okay. Now, if we read that again, notice how both of the bearings were given from point A. So what I'm going to do is I'm going to actually draw point A first. Once you have point A labeled, then you can start sketching those bearings to points B and C respectively. I put point A on the left-hand side here, by the way, because they're both are going to be drawn in a northeasterly direction. So northeast is kind of like heading up and to the right here. So when you're trying to figure out, what your picture looks like, just, I guess, be smart about where you choose that initial point A to be located. Okay, so here's north. To get to B, it's north 23 degrees, 20 minutes east. So that's actually not a very large angle, right? 23 degrees, 20 minutes. So see if you can kind of label that appropriately there, right? There's 23 degrees, 20 minutes. And then the bearing of from point A to point C is north 76 degrees, 40 minutes east. Okay, here would be directly 90, right? So 76 degrees, 40 minutes east might look something more like this. Let's see. Pretty close to that 90 mark. Why did I make point C so much further away? Well, I was actually just remembering that A was 15 miles from B, but it's actually more than double that distance, 31 miles from ship C. So I'm just trying to make my picture accurate. I mean, to be honest, if you didn't go out that far, it's definitely not a huge deal. But that whole angle there is 76 degrees, 40 minutes. I might hold off on labeling that angle for a second. Okay, I'll connect points B and C to make the triangle here because that's what we're trying to find. Find the distance from B to C. And what we know, again, going back to that first sentence, is that A to B is 15 miles and A to C is 31 miles. So if we fill those in the diagram, if I find the measure of this angle inside the triangle, that's the key to this whole thing, is that we really want to find angles inside the triangle. The outside angle here, or this whole bearing of 76 degrees, 40 minutes, isn't really all that helpful to me. But hopefully you can see that a quick subtraction, right? Take the 76 degrees, 40 minutes, subtract 23 degrees, 20 minutes. Here's kind of a quick trick to that, by the way, instead of typing in those angles. If you just do the 76 minus the 23, that's 53 degrees, right? And then you can subtract those minutes. So 40 minutes minus 20 minutes would be another 20 minutes left over. You know, feel free to do that on the calculator as well with the minutes typed in, but that might be a faster way to go about that. Okay, now that I know the angle in between, if we're deciding, is this law of cosines or law of sines? We currently have a side angle side setup. And when you have side angle side, I really hope we're going to default to law of cosines at that point. So law of cosines would be x squared equals 15 squared plus 31 squared minus 2 times 15 times 31. And by the way, if you feel pretty good about law of cosines and you want to kind of like skip ahead to the next example just to see what it looks like, you know, feel free to do that. Check out these solutions or kind of fast forward and jump to that point, completely up to you. Okay, so if I type that whole thing into the calculator here, we've got 15 squared plus 31 squared minus 2 times 15 times 31 cos of 53 degrees, 20 minutes. All right, assuming I typed all that incorrectly, x squared is 630.64, dot, dot, dot. Square root to get that x equals the square root of 25, so 25.1, or we'll go to the nearest mile here, 25 miles would be the distance from B to C. Okay. All right, so again, if you want to go back and repractice with any of this stuff, certainly feel free. But there's definitely some good practice in the suggested practice section, and you'll see some good questions just like this on the review too. A couple of other different types of looks for this question. Here's one where a ship is sailing due north, and at a certain point, the bearing of a lighthouse is 12.5 kilometers distant. Okay, so 12.5 kilometers away, and the bearing is north 38.8 degrees. So the ship is sailing, and then we stop. And we're like, oh, hey, look at that lighthouse over there. The bearing of the lighthouse is north 38.8 degrees east. There's the lighthouse. And the distance from the ship to the lighthouse at that point, we know, is 12.5 kilometers. Okay. What happens? Well, later on, the captain notices that the bearing has become south 44.2 degrees east. So I'm hoping that you guys realize that, okay, we're going to sail due north still. We're still heading north. But in order to stop and have my bearing be south 44.2 degrees east, I'm going to have to pass this horizontal, this east-west line, such that when I go past that horizontal, now it's going to be a bearing that's due south, right? So you're going to come up here to a certain point. and stop and say now my bearing is south 44.2 degrees east. So it might look something like this. That would be east of south. And there's my 44.2 degrees. And the question says, how far did the ship travel between these two observations? So here was the first observation. There was the second sighting. How far did we travel between those two? Okay, so this should actually be, once I have the picture, a pretty quick setup because we have two angles that are already on the inside of the triangle. That's actually the first time that's happened in these three questions. The last two, we had to do a little bit of work to determine that. But if I just do a quick 180 minus here to find out the last angle, which is necessary, 180 minus 38.8 and 44.2 leaves me with 97 degrees over here. Now it's just going to be a quick law of sines. So we're going to have x over sine 97 equals 12.5 over the sine of 44.2. Cross multiply. And finally divide both sides by sine 44.2 to get that the distance that the ship traveled in between those two observation points is, all right, double check I typed this in correctly. That looks good. 17.8 looks like what it would be rounded. So we'll say it's 17.8 kilometers. Okay. Now, the reason why I'm walking through all these examples in the notes today is not because I'm trying to make the longest video possible. They're actually really all different examples of what the diagram could look like when you're working with bearings. So for that reason, if you find other examples that you're like, oh, I'm not sure what to do, you should be able to look back at this video or at the notes and find an example hopefully pretty similar to it, and maybe that will help you get it set up. But we do have two other looks that we're going to look at in number 3 and number 4 here. So if we take a look at number 3, let's see if I can just slide this over here. Okay, a ship leaves its port, still sailing around, right? We're still got this whole boat thing happening here. Mickey's sailing around the world, such a world traveler here. On a bearing of north 25 degrees, 20 minutes east. Another ship leaves the same port at the same time on a bearing of south 64 degrees, 40 minutes east. If the first ship is at 18 miles per hour, some speeds being thrown in the mix here. And the second is at 12 miles per hour, find the distance between the two ships after 5 hours. Okay. So these two ships are leaving the same port. Here's the port. And again, the reason why I'm putting the port on the left is because both of these are going to be headed east at a certain point. So east on your page should be going to the right. Okay, first ship, north 25 degrees, 20 minutes east. So here's north, 25 degrees, 20 minutes, not a very large bearing. Might look something like that. Okay. And then the other ship is at south 64 degrees, 40 minutes east. So notice how we have to this time start by drawing a line due south from that same port and rotate 64 degrees, 40 minutes east. So that's definitely a larger bearing than what we had for our northeast bearing. So that's this right here. Okay. So I have those two sketched in, and I want to figure out what's the distance between the two ships after 5 hours. So if I connect this distance right here, that's what I'm trying to find. Okay. Now, one key to this is, again, we know the speeds of each ship. One's at 18 miles per hour, one's at 12 miles per hour. So based on that info, we can find how far away the ships are from the port after 5 hours. So 18 times 5 would make this a total distance for ship 1 of 90 miles. And then this distance right here would be 12 miles per hour times 5 would be 60 miles away from the port. So now that I have those, really the last thing that we'd probably want to identify is what's this angle on the inside? And notice how this angle in this scenario completes half of a circle. So if I do 180 minus those two angles, you're going to be getting this angle right here. All right, let's see. 64 and 25 is a total of 89 degrees, if you're with me on that. And guess what? 20 minutes and 40 minutes adds up to a whole degree. So these two angles total 90 degrees, which means how much is left on the inside here? Another 90 to complete 180. That's actually a right angle. Doesn't happen all the time, but if it does, it's kind of nice. Boy, I did a nice job sketching that. Look at that right angle. That looks like a right angle to me. Maybe I cheated because I knew it was going to come out to be a right angle. Maybe I didn't. Maybe I'm just that good. I don't know. But anyway, so yeah, we got a right angle going on right here. Okay. So to find this side, well, you can do one of two things. I'm going to choose the easier route. The harder route is law of cosines, because we have side angle side. And at the end of law of cosines, you're going to put cosine of 90 degrees. Guess what cosine of 90 is? Give it a second. Cos 90 is 0. So all that business at the end of law of cosines would actually just go away. And what this is going to turn into is actually Pythagorean theorem. If you have two sides in a right triangle, you could do Pythagorean theorem. You could do 60 squared plus 90 squared equals x squared. And again, if you did law of cosines, you are doing essentially this because the end of the law of cosines would just kind of go away. All right, I can do that quickly on the calculator. 60 squared plus 90 squared. And get that we have 11,700. And if I take the square root of both sides, the distance that those ships are from one another is about 108 miles. So oops, that's not going to be a 108. We'll say x is 108. Okay. Last but not least, here we go. All right, and I like this one. This one's kind of fun. It's a little bit different than, again, any of the ones that we've done so far. Really 5 different looks here, guys, at some different bearings questions. Finally, a ship leaves its port, sailing on a bearing of north. Boy, we never had west, I feel like, but we're going west finally. North 54 degrees west. It travels 23 miles, changes its course to south 25 degrees west. Travels along that course for 35 miles. How far is the ship from its port? To make our diagrams as accurate as possible, I really think reading it through once is a good idea. Then maybe set up the picture the second time through. So the ship was leaving on its port north 54 degrees west. I'm going to start the port on the right side of the page now, because if I'm being accurate about this, going west is going to head left. So here's north 54 degrees west. A little bit more than halfway to 90, right? Okay, so that angle right there is 54 degrees. And it travels on that bearing for 23 miles. So we'll go ahead and label that. Okay, then it stops and changes its course. So pretend like it docked here for a second. Then it's like, wait, hold on. I want to go south 25 degrees west. So this little angle is going to be 25. And I'm going to travel on that bearing for 35 miles. Now, that 35 miles to me is pretty important when I draw my picture, because a lot of students, when they draw this in, they like to stop so that they're in line horizontally with the port. But that actually wouldn't be true, right? I mean, if I go 35 miles, definitely longer than 23, the ship is actually somewhere down here. So I want to figure out what is the distance that the ship is from the original port. And we can get really lulled into a false sense of security here if we stop in line with the port, because then you might try and do that right angle thing like we did earlier. But that's actually not true in this example. We can't quite do that. So we need some other info. We definitely have two sides of the triangle. To find this third side, let's see, if you have two sides, not a lot of angles going on the inside. In fact, I don't know any of these angles yet. It's probably going to be law of cosines. But if we look at the only piece that I know that this is 25 up here. If I knew this other part, then it would definitely be law of cos, because we'd have side angle side. And I'm pretty sure that we can find this piece. I'm going to give you a second to think about it here. Maybe you see what it is. But for those of you at home shouting out the answer, did you know that it was 54 degrees? And 54 should sound pretty familiar from earlier. Take a look at these two bearings. This bearing right here that was northwest is going to be equal in measure to this bearing. That would actually be, I guess, the southeasterly bearing, right? So the reason why those two are equal is because these two lines, north and south, are parallel. So if these are parallel lines, these are alternate interior angles. So they have to be congruent. Now that we know that, the total angle up here is 25 and 54 for a total of 79 degrees. And then once we have that filled in, we can use law of cosines. X squared equals 23 squared plus 35 squared minus 2 times 23 times 35. And at the end, we've got cos of 79. Okay, put all of that into the calc. X squared equals 23 squared plus 35 squared. Minus 2 times 23 times 35. Cos of 79. 1,446.79 ... Square root. To get that, the distance the ship is from the port is 38-ish miles. Okay, so we'll round to the nearest mile here and say that that's 38. Okay, and that is it. You now know everything there is to know about trigonometry, or at least what we're willing to cover of trigonometry in pre-calculus. I'm sure there's a couple things we've left out. But anyway, as always, bearings can be a tougher part of this course, if I'm being completely honest. So as you're doing practice, if you need help setting something up, send me an email. I hope that you'll contact me, and I could even send you a picture of what the diagram should look like, maybe. Also use the answers that I've posted at the bottom of the website for all those suggested practice problems. Maybe all you need is to confirm that your picture's right before you try some law of sines or some law of cosines. All right. We really appreciate all the work that you guys are putting in and that you're sticking in there through our distance learning that we're all taking some time to get used to here. This video will be posted later today, and I hope you guys are all safe and healthy out there. Look forward to talking and hearing from you very soon. All right. Have a great day, guys.